Wow. I heard Nur Alia Afifa. Yes, your name is same name with my wife. Okay. My wife named Nur Afifa. Ah, okay. Okay, good to hear about you all. So, do you have any planning to go to where, or maybe to go to overseas, Korea, Japan, and so on? No? Oh, hey. Assignment and project law. Okay. My who assignment and project. Okay. What assignment? Berenang je kalau nak pergi overseas. Okay. Tennis. Tennis, I think you can use your flying jet, right? Okay. Because you are tennis, right? Okay. We are still waiting for others to join. Forty-two. All right. Today class, we try to finish up the root locus if we have time. Okay. I think, and then next week will be your mixed metabolite. So I wish you stay at home and stay safe. Okay. Right. Okay. So can I start the class now? Boleh ya?
Boleh.
Boleh, sir.
Okay. Where is our doctor? Now the Johor Bahru is quite critical, right? The numbers of COVID-19 is increased day by day. Okay. All right. Doctor on call. Okay. Good. Last Sunday, yes, we have learned about root locus. Okay. So we have draw a root locus there. By the way, there are some rules that you need to follow. Okay. And the most important thing is the starting point is the open loop transfer function, KGH, right? And then you plot them. If the pole, you make a cross, or zero, you make a circle, right? And this is the rules, right, for the locus. So the girl cannot meet girl, man cannot meet man, right? So if you have a pole and pole, that means it will be some breakaway. Okay. So for today, we will look if we have a complex pole. So based on this guideline, we can see that if the pole are zero or complex number, the root local are symmetrical about real axis, right, of the S-plane. Okay, we will look into that. So we just only to scan the upper part of the root loci and mirror that one. Okay. All right, and then you have done this one, determine the asymptote and so on. Okay, we also have done this one, breakaway and breakpoint. So, and then we want to see what we call it. Okay, number 9, we're not done yet for the complex pole. We will see that departure angle after this. And the intersection for the imaginary axis, so we can do that by using the root stability. So we can find the root table, right, using that. And then we have done this one, done. So after that, we can see the intersection point. It should be 96 here, right? Okay. Then this one, the intersection there. All right. Okay. And for example, 4.4, I just we just go through lah this one. So you are given KGH, open loop transfer function, and then from this one you can find the zero. All right. So in this case, you don't have any zero. You don't have S plus something. You only have the pole, right, which is equal to -2 and also -4. So that means the zeros is 0, the pole is 2. So this one, in order to find the number of asymptote. and then you plot it by using x cross cross for the pole and zero circle for zero. You plot it, and then next one you draw the root locus on the real axis first. Okay, so you can see that these two poles that lie on the real axis, so you just draw it. So because you have two poles here, so there will be some break away, right? Fine. Okay. Sorry guys, my daughter, I I asked her to sleep, but she in hyperactive now. Okay, and then uh, determine the asymptote angle. Okay, and then you find P and so on. The based on this asymptote angle is depending on your number of asymptote. Okay, so asymptote that means the guideline in order you want to draw the locus. So for example, this one you got it the asymptote angle equal to 19. So that means you draw this one to be 19. Okay, but in order to draw this one, you need to find the asymptote centroid first. So how to find the asymptote centroid? So the summation of pole, right? That means you only got it -2 and -2 plus with -4, and you don't have 0. This one will be -6, and then divide with number of asymptote P minus Z. So 2 minus 0, you got it -3. So that means your asymptote centroid as a -3 here. Okay. Then you need to draw two asymptote. One is 19 and the other one is 217. So that means this one 19, 180, 217 here. Right. So this is the asymptote. Okay. And then after that, we need to find the breakaway because this is two pole, right? So there will be some breakaway. Okay, so how to find the breakaway? So you need to use the characteristic equation 1 plus kgh. All right. From that one, you need to find dk over ds. There we find the k here. So we find the dk over ds. Okay, this one, dk over ds equal to 0. And then you got it 2 plus s plus 6. And then you got it is s equal to -3. So that means the breakaway will be also at -3 also. Okay, at here. And then, okay, so you draw the root locus. Okay, done. Intersection, that means there is no intersection, right? Because you can see that the asymptote angle going straight. Okay, so that means your root locus will be go straight. Okay, so there is no intersection to imaginary axis. There is no intersection. Okay, good. So then you complete your drawing. So you can see that this pole, the first pole, it can be going down, right? And the second pole, it can going up, right? Right. So it doesn't matter if you write it going up and going down, right? But in order to know detail how it's going down, going up, so you need to do like on what I told you before. You need to put it the value of k here, right? If that's it, then you try to find the roots, right? K equal to 0, k equal to 1, k equal to something. Okay. All right. That's it. Example 4.4. All right. I hope that everyone can take a piece of paper. We can do it together. Maybe you can share it to me how you draw your root locus. Boleh eh? Okay, everyone. So I want to do this example 4.5. Okay, done. Right. So example 4.5. Draw the root locus for a control system with open loop transfer function given as kgh. Okay, you are given kgh equal to k times s plus 2 divided with s squared plus 2s plus 4. So for today, we want to look if our system, right, have a complex pole. Okay, so what happened, right? So I hope that you take out a piece of paper and then you can follow my step. Okay, so that you can learn it, right? So first one, you need to locate the zero and pole. Okay, pole and also zero. So right now we have pole zero first. Okay, zero. Zero now you have, right? This one. Zero, you that the root that you look at the numerator, right? This one, the denominator. So now you have the zero. Zero is minus 2. Okay. S plus 2 equal to 0. So you got it minus 2. That means the Z now is equal to 1. Right? And also pole. So you will have a complex number here. What you got it is minus 1 plus 1.73j, and also the other one is minus 1 minus 1.73j. Alright, so this means your pole now is equal to 2. Alright, this is the first step. So you locate pole and you locate the 0. And then number 2, okay. Yeah, my little daughter having their her own business right now. Just ignore it, right? Okay. Hey, Mr. Papa cannot do anything. Hey. Okay. Now you draw the you got it minus 2 and so on. Okay. Now you need to draw this one. Okay. So this one is 0. Let's say this one is minus 1. And yeah, just take it. Minus 1. This one minus 2. This one minus 1.5. Okay. 1, 2, 1, and 2. Okay, done. This one imaginary. Okay, J. This one is real. Okay, we are done there. Okay. Now what do you have? You need to draw the pole and 0 at the S-plane, right? Zeros, now you have the minus 2. Okay. Yep. So you have here minus 2. 0, that means you made a sum circle there. Okay. And then pole, you have it, this one is 1.5. Okay. Pole, you have it minus 1 and plus 1.7. You got it here. Okay. Okay. Alright. And then this one is like this one. Okay. Now, 2 pole and 1 0. Okay. Now, what will be happen? Okay. So we will look after this. Okay. So far, do you have any question about this? Clear? Huh? No question? No. Okay. Let me look the chat. Okay. No. Okay. Good. And step number 3, you draw the root locus on the real axis. So now you don't see any the root locus that you can draw, right? Because there is no pole 0, right, in the real axis. There are no pole, right? You can draw no. So step number 3, yep, you can skip it. Okay. Step number 4. Step number 4, you find the number of asymptote. So P minus Z. So we have the P is equal to 2 minus 1. 2 minus 1, you got it 1. Okay. That means there is only one asymptote there. We will look into that. And then after that, number 5, you try to find the asymptote angle. Okay, this is the formula of asymptote angle is 2r plus 180 divided with p minus z. So because you have only 1, so it will start from r equal to 0. Okay, then you got it is p equal to 2 times 0 plus 1, 1, and so on. So it's equal to 180 divided with 1. So your asymptote is at 180. Okay, so this one. Alright. And then you need to determine the number of asymptote. Number 6, number of asymptote centroid. So sigma A is equal to summation of pole minus with summation of 0 divided with number of asymptote. So P minus 1 plus 1.73J minus 1 minus 1.73J, and then minus with the 0 is minus 2 divided with P minus Z is equal to 1. So here we got it is 1. Yeah, this one we cancel out. Yep, this one we cancel out. So minus 1 plus 2. So now you got it is 0 here. Okay. Right. So this is your asymptote centroid. Now you need to draw the asymptote line. So how to draw the asymptote line? Your asymptote centroid at 0 right here. So it will start at 0, you draw it, the asymptote. It almost near with the what we call it, the real axis. So this one the 180, and your this point is call it the asymptote centroid. Okay. So far so good? Boleh? Guys? Hello?
Boleh Doktor, boleh.
Boleh Okay. Alright. Done. Okay. We are done. Alright. So, right now, find the breakaway if the breakpoint exists. Okay. Alright. Okay. So, now we look at you have a 1 pole and second pole and also 1 0. So, the concept is one of the pole we try to find a 0, right? We try to find a 0. Okay. Right? So, it will be like the circle one. Okay. However, in order to find the 0, right, it will have some breakaway point here. Okay, you will look to that. Okay, now the next step is you can find the breakaway point. So that means you need another mathematical solution on that. So number 8. In order to find the breakaway, dk over ds equal to 0. Now you need to have the 1 plus kgh equal to 0 here, and 1 plus k s plus 2 divided with s squared plus 2s plus 4 equal to 0. And when you settle out, you can get it k here is equal to minus s 2 to s plus 4 divided with s plus 2 here. Alright. And then in order to find the dk over ds, alright. So remember this one, the formula you need to find the what is it, du over, I think that one is du over ds. Okay, du over ds minus with u dp over ds divided with b squared. Okay, let me write this one. du. Okay, done. Then that's mean just take it u. Okay, so s squared plus 2s plus 4, and then you can now find the u of ds here. So equal to 2s plus 2. Alright, and then your v you can take out it as plus 2, then you can find dv over ds here equal to 1. Alright, and then you settle out this one, you put it, and then you will get it a simple thing, this one, dk over ds equal to s squared plus 4s. Alright, and dk over ds equal to 0, so you can get it as s plus 4. Now you can get it is s equal to 0 and also s minus 4. Alright, so which one to be choose, right? So we can choose is minus 4. Okay. Okay. Alright. Alright. So far, do you have any question? I think this one, so you need to solve it by using this formula, right? So we have look at this formula, right? During your, I think form 5 and so on. Okay. Alright. Okay. Ada apa-apa soalan berkenaan dengan ni? Simple ke? I think you can follow this this note. Okay. Alright. Alright. Okay. Number 9, why this one have the breakaway? Okay, for the complex pole and zero, the point where the locus meet the real axis is the breakaway point. Okay, we will look into that. Okay. Alright. Alright. Okay. Okay. So now this one minus 3 here. And this one is minus 4. Okay, so this will be the point, the breakaway point. Okay, yeah, that means this pole, the root locus after this, it will try to go to this point first, and then it will go to 0. We will look into that. Okay, all right. Number 10, you find the intersection of the locus with imaginary axis using the stability of criteria. Okay, if you look into that, there is no what we call it intersection to the imaginary axis because of your asymptote, right? Your asymptote is 180, right? 180. Okay, so that means your pole, the root locus from the pole, it will go to the 0 and it will stop at the 0. So last class, so we have do that. The root locus we start from the pole, so that means k equal to 0, and then it will end at the zeros, right? So k equal to infinity, right? So we have done this one on our last class, right? So that means this one k equal to 0, and then it will end at the k equal to infinity. So that means there is no intersection into the imaginary axis. Okay, if have the intersection, that means you need to what we call it do the root table criteria. Okay, and the more important thing is you need to find the departure angle. That means your locus here have a departure angle. Okay, how to find the departure angle? All right, guys, so far so good. You can follow, right? Boleh Diam je.
Boleh Doktor.
Boleh Okey. Muhammad Azmi suara
Boleh,
macam
sir.
perempuan je. Okey. Alright. Okay. So how to find the departure angle? Departure angle. Okay. So actually you can draw at your graph lah. Okay. But I just want to draw it here. So now this one your pole and this one your another pole. Okay, so this one the axis. Okay, now this one the value is -1, and this one this value, right, is 1.73. Okay, so where I got it, this one, right, 1.73 here. Okay, 1.73. Okay, now the first thing that you need to do is you need to connect the pole, right, this one, all to be at 0. Okay, all right, you understand it? All right, connect this one, then all right, okay, so you just choose one pole here, right? And then we want to see the departure angle. For example, we want to see the departure angle from the pole here, right? Because the pole we going to 0. So we want to see this departure angle. So how to see that? That means you just connect all pole or 0 to be at here. Okay, connect here. So how much the angle of this one? So this one is angle is 90 degree. Okay, and how much the angle from the pole to 0? So we can find that. So this one is equal to 1 because the 0 at -2 -1, so the differences is 1. Then you can find this one, what I call it, sine theta is equal to 1.73 divided by 1. Then you can find the theta is about 60 degrees. Okay, so we can find that this one is 60 degree. Okay, we're done. 60, 19. Okay, 60 and 19. All right. Then we can find by using this formula. All right. So the formula is the departure angle, right? Departure angle from the pole is equal to what the formula? Okay, departure angle. Departure angle. Theta D is equal to 180 minus with summation of pole, okay, and then summation of angle 0. Okay, so 180 degree minus with the pole, okay, this one, this pole, right, okay, pole, right, the pole, so that's mean 90 degree, okay, and then from the 0, so you plus it with 60 degrees, okay. This point choose one pole, and then we will look what is the angle, right? This one pole to here is 90 degree. Okay, done. Right? And this row to pole is 60 degree. Done. And then you can find that is 150 degree. Okay. Done. Okay. For this part, do you have any question? Ada persoalan tak? Doctor, is that tangent theta? Oh, sorry guys. Good, good. You are good. Sorry. Tangent theta. Good, good, good. Sorry. Hampir I miss tangent. Right? Yep. How about this? Okay, good. Okay. Do you have any question? This one? No? All right. Okay. So we just find out only one pole, right? Because this one will be what we call it as symmetrical with this one. We will look into that. Do you have any question? Ada apa soalan? No?
Okay.
Okay. So we already got this one. So let's look where we going to put the departure angle. Okay. Now we know the departure angle is 150, right? So going back to here. Now 150 is about, yep. Okay, this one is about 150. degree. Okay. Alright. Done. So how to draw the root locus? So the departure angle, right? This your pole, it will departure 150 degree, and then it will go to this breakaway, and then it's try to find the 0. So this will be your locus. So this is what the departure angle use. Okay? Can you get it? Boleh dapat? Boleh tak? Boleh eh? Okay. Alright. So the next thing is one pole. It has choose this one, right? One pole have choose this one. Okay. So how about this one? It's only symmetrical. Okay. 150. 150 is about this one. Okay. Right. Right. So your locus now it will be symmetrical. Okay, this one going to 4, but it's going to that. Okay lah symmetrical. But the size is not symmetrical. Okay, this will be your locus. Alright. Now you will see that this one is starting for k equal to 0 and it will end at k equal to infinity. And this one is k equal to 0 and then it will end to k equal to infinity. Okay. Then this one is about 150 or so. Alright. Okay. Now, is it clear? Okay. Someone want to share what he has drawn? Maybe you can share on the screen. Ada tak nak share? Dah buat? Ataupun tak buat? Dengar je. Guys, ada yang buat tak? Maybe boleh nampak dia punya drawing. Oh, terus left. Sazwan Ma'ruf. Left terus. Guys? Yuhu. Sengak je. Nur Alia Afifah.
Ada.
Ada.
Masih lagi.
Nur Alia Afifah nak share ke? Awak dah draw ke apa? Root locus. Dia tak buat dah ni. Aduh. Inilah kelas online ni susah lah. Right. Ada ke yang buat? Anyone? James Kwek? Ada buat. Ada buat. Okay. Maybe you can share. Do you want to share? Wow. You can share on your group.
How to share? I don't know
How to share.
WhatsApp
Okay.
boleh.
Alif also. Terbalik ni. Macam mana ni? Macam mana nak buat ni? Sekejap ni draw terbalik ni. Draw macam tu je. Simple je. Okay. This is what have been drawn by your friend. Terbalik ya. Macam mana lagi terbalik? Ni, lagi terbalik. Wow. So simple. Okay. Aduh. Macam mana macam ni nak dapat full mark ni. Okay. There is no dotted line. Okay. Dafa. Good. Okay, good. Everybody have chess. Yeah. So, okay. Alright, good. Okay. This is what we want. Okay. Alright. Good. So you have draw this one. Okay, good. So this one what we want. Okay. Right. And then you can draw the locus here. Right. Pole going to this and going to 0. Okay. Someone else? Wow. Oh, rajin rupanya semua ni. Okay, ingat ke tidur? Right, good. Who is this? James Quack. James Quack. Where is your blue colors for this one? Okay. The pole is going, try to meet the 0. Okay. You need to have one blue color here. Okay. Meet the 0. Okay. And this one, the right color, another root locus. Okay. Going to this. Actually, the locus, right, is not touch the real axis, and also it not touch the what we call it, the asymptote, right? It almost touching. Okay, almost touching. Okay, okay. Zikris, Zikris pula dah. Zikri. Okay. Okay, good. But you should have another local there going to infinity. Okay. Tennis, tepuk tangan saja. Memang dasar tennis Macam tu. Okay. Tennis. Where you drawing? No. Still searching. Okay, still drawing, right? Okay. On the way. Okay, on the way. Yeah. Alright, good. So this one, the example for 4.5. Good. So I hope that you can clearly understand about how to draw the locus, how about the complex pole, and so on. Okay, so let's move to another, what we call it, another example. Okay. Wow, okay, tennis buat, bagus, cemerlang. Good. Okay. Alright, so can we proceed to another example? 4.6. Wow, you're cute. Go there. I'm having a class now. Okay. Alright. Example 4.6. Alright. Yeah, I need to draw it again. No. Okay. Okay, I just go through lah. Okay, example 4.6. Alright. Everybody, can we proceed? Boleh Okay. Okay, example 4.6. What do you have now is KGS. So first, you need to locate pole and zeros. Okay. Wow, Daniel Fidos ni baru bangun tidur ke? Okay, zeros in that open loop sample function equal to -2, and then z equal to 1, and poles you got it is 0, and also 1 minus 1 plus 1 7 3j, and also -1 minus 1 3j. Okay, so and then you got it p equal to 3. Okay, so you can get the number asymptote there. Alright. Oh, can I undo? Why I delete all that thing? Okay, tak boleh undo Hey, you need to draw it again. Okay. Why is it 0? -1. 1 minus 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 minus 2, minus 3, 1, 2, minus 1, minus 2. Okay. Now you got it is minus 2 here, 0, minus 2, 0 here. Same thing, right? Same thing with the test before. 1.7 or minus 1, then minus 5, so it will be here. Okay, then you got it 0 here, and then this one got it this one. Okay, done. Alright, so we are done there. Alright, first number 3, step number 3, you draw the locus on the real axis, right? So now you can see that you have one pole here and then 1 0. So it will go to this one first. Okay, this is your locus, first locus. Okay, then this pole don't have any partner, right? So it try to go anywhere, try to find the pole. Okay, right? So we are done. So we will determine the number of asymptote, okay, is equal to 2. Determine the number of angle equal to asymptote angle 19 and 217. And the asymptote centroid at 0 here, at 0 here. So the first asymptote is 19. So this one is 90 degree. The first asymptote, and another asymptote is 200 and minus 90 lah. Okay, 270. Right, we are done. And then is it there is a breakaway, right? It's no breakaway, right? Because this pole try to find the 0, but this 0 is already carried, right? Okay, right. That means there is one girl, so there are 3 men, right? Try to compete each other. So this man got it, right? Good. Ha ha ha. Okay, and then what else? No breakaway. Okay, no break in and so on. Intersection. Do you have any intersection here? Right? You don't have any intersection here, right? Because it has been blocked by the asymptote. Okay, have been blocked by asymptote, right? So no locus can cross the imaginary axis. Okay, and then you need to find the departure angle. Okay, the departure angle for this one. All right. So how to find the departure angle? Sarah, I'm moving fast. Go there. Oh, battery lower. Low battery, below battery, low battery. Nah. Go, take mine. Okay. How to draw? How to find the angle of departure? Okay, now you got it this 2 point here, 2 point here, and you got it this one. Okay. Yeah, actually, if you want to make it clearly, you can draw this one. Okay, we just choose this point. Okay, throw. Okay, and then this one. Okay, and then this one. Okay, done. So this one will be 1.73. So this one will be 1, and then of course you got it here is 60 degree. Okay, based on tangent, right? So tangent theta is equal to 1.73 divided by 1. So you got it, theta is 60 degree, done. And this one you got it is 90. Okay. How about this one? This one is 1. So this one is 60 degree, right? But we want it to here is 120 degree. Okay. Alright. So for the pole, we got a two angle 90 degree and 180 degree. For the zero is only 60 degree. Okay. So angle of departure summation 180 degree minus with summation of angle pole plus with summation of angle zero. 180 degree minus pole, you got it 90 degree plus with 160 degree, and angle zero you got it only 60 degree here, and after that you can get it is 30 degree. Right, so that's mean your angle departure, right? So equal about 30 degree. 30 degree is almost this one. Okay. So this one is 30 degree. Okay. And this one is also 30 degree here. Right. Then how to draw the locus here? Your locus start here, right? It's going to find the 30 the asymptote, right? Okay. So you go 30 degree and you go there. So this is your locus, and another one it is symmetrical here. Okay, yeah, okay, now it's going to that. Okay, so this one for the k equal to 0, right, and then going to k equals to infinity. So this one is k equal to infinity, k equal to 0, right? Okay, then do you have any question?
No, Doctor.
Hey Daniel, no. You just joined the class, right?
Sebab tadi saya punya komputer ada masalah, baru dapat start.
Tak apa. As long that
Sorry,
you
ada.
can join. It's okay. As long that you can join. Okay. Everybody, you want to share your drawing? Okay, you can share on the WhatsApp group, right? It's good to see that maybe. Okay. Now, do you have any question about this one? For the complex number, remember need to find the departure angle. Okay. So how to find the departure angle? You just choose one complex number and then make all the line going to this, right? Okay, you just choose one pole for the complex number and then make the dotted line go there. Then you want to find the angle to that pole, right? Okay, so this one the angle to that pole. Okay, right, done. Okay, guys, you're done, right? Okay. Can we take a break for 5 minutes and then we will continue to the next chapter? Is it okay? Boleh? Boleh, eh? Okay.
Boleh.
Okay. 5 minute break, then we continue.
Doktor.
Okay, we are back. Alright. Guys, you who? Can we move to another chapter? Hello.
Okay,
Okay,
okay.
doktor.
Okay. Alright. Okay. Internet. Alright, we got internet. Okay. Now, we have drawn the root locus and so on, right? So we have drawn the root locus and so on. So what can we get from that one? That's mean, um, so what we call it, the information that we can get from that one. So whether that root locus it represent the first order system, the root locus represent the second order or third order and so on. How about the time constant? So how about the damping ratio, right? How about and so on lah. Okay, that's mean. Okay, so transient response of dynamic system is closely related to the location of the pole. Okay, so you can see like here, right? Pole that located on the right hand side will result with unstable system. So we know that if we got a sample, right, is located at the right hand side of the imaginary axis, so you can see that our system is not stable, right? From that one, by draw the pole, right, or zero, so you can see, yeah, our system is not stable, all right? And if the pole with the negative real number, that's mean s plus a pole, okay, equal to 0, so you will call it s equal to minus pole, right? That located on the real axis, right? For example, this one, okay, one pole located like this is. So we can say that this one will react at the first order system, okay? And if you have the system that have the complex number, so it will react as the second order system, where you can see that you have the damping ratio, the natural frequency, omega n, and omega d also, and so on. Okay. So how to interpret the root locus and controller design? Right, so we need to have a closed loop system that have a stable and transient response, right? Depending the time constant and so on. So we have learned about this one. The transient response have a few parameters. For example, the time constant for the first order and damping ratio. Okay, for the second order natural frequency and also the damp natural frequency for the second order. Okay. So for the higher order system, for example, the third order or fourth order system, so how can we interpret that? So by looking the dominance root, okay, dominance root on the root locus of the S-plane. Okay, for example, a third order system has 3 poles. So the 2 dominant pole that are close to imaginary axis are assumed as the value that represented a second order system. Okay, for example, you got a three pole, right? So we can say that our system is react like a second order system, right? Because there are 2 pole that dominance, right? There are 2 pole that dominance. Okay. And from that root locus, we can get it time constant, the damping ratio, omega n, and also the omega d. Alright, and we also can get the K. So this one is quite interesting one, how to calculate the K, right? How to calculate the K. Okay. Alright, so maybe I can show you the MATLAB. Okay. Alright. Similarly, if we know the pole value, right, we also can get it the time constant and so on. Okay. Alright. So the graph will be like this one. Now, imagine that you got it is 2 pole here. So let me draw it again. Okay. All right. Okay. Now you got it is 1 pole and 1 pole here. Okay. And maybe you can got it 1 pole here. Okay. All right. So this our locus, right? So our locus. Okay. So this pole value, right? From this pole value, we can get a lot of information there. Okay. For example, we can get here is omega n here. Okay. The length of this one, we can get it omega length n here. And then at this point, right, we can get it is omega d. Where the formula is, I think you're already familiar with this one for the second order system. Okay, this one. Right. Okay. Now you can see that your locus, right? For example, your locus going to there, okay? Let me draw it clearly for you. Okay. So, for example, your locus, you have something like this one. Okay, the circle one. So, if your root at this point, that means damping ratio equal to 0. So, do you still remember when you got it, your damping ratio equal to 0, you will got it is something graph like this one. That means there will be a lot of oscillation there. So that means this one will be unstable. Okay. Right? Remember. Okay. And if your locus is at there, at this point, so that means you will got a damping ratio equal to 1. So remember the damping ratio equal to 1. Now you will got it, the graph is like the first order. Okay. Right. So if your root locus is located at something like this one, right? Or maybe this one, okay? So that means your damping ratio is Alright, the damping ratio we can say that less than 1, more than 0. So this one, remember the last time, less than 1 that equal to 0. So now you can get it, the graph will be like second order system. Okay, so from this one, we can get it the damping ratio, and also you can get the omega n, and we also can get the MP and so on. Okay, overshoot. And also we can get it for the first order is time constant here. Okay, so for this topic, I'm going to show how can we get all these parameters, T, damping ratio, omega n, and so on. Right? Okay, so let's look this one. Okay, and the point at this point, it will be damping ratio omega n equal to 1 over time constant. So you can get the time constant from here by knowing the damping ratio and so on. And then there are beta here. Okay. Yo. Wait a minute, guys. Okay. Go there, Kaisara. 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 Ambil ni. Take this one. Kaisara. Yeah. Okay. Then omega n. This one omega t. Done. Okay. So this is information we can get it. Time constant, omega n from here, and also we can get the damping ratio is given the time constant and so on. Okay. All right. Okay. All right. So let's look. Okay, this information that you can get. So how to get the damping ratio? You can get it is cos beta. Okay. Right. That's mean the cos beta. That's mean it is like damping ratio omega n divided with omega n. So you can get the damping ratio. Okay. Okay. Right. And then you can get the omega d from here and so on. So time constant is equal to damping ratio. Time constant is equal to 1 over damping ratio omega n. Okay. Right. So from this pole and so on, we can get for this parameter. Right. And then if you can get this parameter, you can draw lah. You can draw the response and so on. Okay, now the introduction for this topic, is it clear? Faham tak? We have draw the root local, so how can we interpret? How can we get the information from that? Boleh Right? We will look the example. Ada apa-apa soalan tak? Clear tak? Clear Okay. Guys? Yuhu? Yuhu? Clear? Do you have any question? No? Okay, good. Alright. Let's look the example 4.1. Okay, before this, we are given the straightaway KGH, right? Now we want to look, you are given the closed loops block diagram, K and 1 plus something and so on. Alright, now draw the root locus when the K increase from 0 to infinity lah. Okay, right, and the B, if the given when K equal to 10, the root locus of reciprocal equation minus 3 and minus 1 plus 2.24J. Okay, we will look into that. Right, so now you need to draw the root locus. So by given the block diagram, you need to find first the open loop, KGH, right? KGH, that means you got a K, and then you time with 1 over S plus 1 and S squared plus 4S plus 8, done. And then H, now you got it only 1. Okay, then you got it KGH is K S plus 1 and then S squared plus 4S plus 8. Okay, this is the case here. Remember, from the block diagram, you will get the open loop sample function first. And then step number 2, locate pole and zeros. Now you got it is zeros is equal to 0. There is no 0. That means Z equal to 0. And then you got it pole minus 1. And this one is minus 2 plus 2J and minus 2 minus 2J. Okay, this is the information. Alright. And then step 3, you can get the number of asymptote P minus Z. So this one is P equal to 3. So 3 minus 0, you got it 3. And then number 4, you determine the okay, you start to draw. Minus 1, minus 2. Okay. Now it's 0. Minus 1, minus 2. Let's say this one minus 1. Minus 2. 1, 2. Minus 1, minus 2. Okay, can. So next what you're going to do, you just draw. You don't have 0, you don't have 0. Okay, now you got it a pole. Pole is minus 1. And the rest is here. And the other one is here. Okay. Alright. So next thing is you draw the locus on the real axis, right? So if you look at that, you only have one pole here, right? So it try to find 0, right? So first pole is going to the left. So that means this one is going to here. Okay. So it start from k equal to 0 and going to k equal to infinity. Alright. So this is draw the locus on the real axis first. Done. And then you determine the number of asymptote and so on. And then you got it is the asymptote centroid 1.67. So it's almost 1.5, 1.6. Okay. And 60 degree, 180, and also 300. Yep. Okay. So you got it is 3 asymptote there, 1, 2, 3. Okay. And then the breakaway, nope, there is no breakaway. Okay. This pole going to find what we call it 0. There is no. Okay. All right. No breakaway, and but in also no intersection. Yep, it will have some intersection there. This pole going to follow the asymptote, right? So it tries to cross the imaginary axis. Alright. So how to find the intersection on the imaginary axis? So you need to use the root table. Okay. So number 11. So you need to use the root table. So find back this characteristic equation 1 plus kgh equal to 0. That means 1 plus k divided with s plus 1 s squared plus 4s plus 8 equal to 0. Then you got it is s cubed plus 5s2 plus 12s plus 8 plus k equal to 0. Alright. And then you do the root table s3, s2, s1, and also s0. Okay. So remember, s3 the coefficient is 1. then you skip 12. Then 8 plus k is together. So this one is 5, and then x plus k here. Right? The other one is 0. This one is divided by 5. So 5 times 12 is 60. Alright. Minus with 8 minus k. Right? Then you got it is here is about 52. Minus k divided with 5. And then the rest is 0. And this one turns out you can get it is 8 plus k here. Okay, right? So I think you remember this one, right? And then in order to find the k is 52 minus k divided by 5 equal to 0. Then you can get it k equal to 52. Okay. Alright. Done. And then from this point, you need to find the root, right? You can choose this one. Why you choose s power of 2? Because in this intersection, right, you got a 2 pole, right? So you will have 2 intersection there. Okay. Alright. So that's why you choose s power of 2. So s power of 2, that means 5 times 5 s power of 2, 5 times s power of 2 plus a plus k, right, equal to 0. Right. So now you got it as squared plus this one 8 plus 52 equal to 0. 5s2 equal to minus 60. Then you got it as plus 2 is we got it minus 12, and you can get it as equal to plus minus 3.46j. Okay, all right. So this one we got it here, right? So that's mean coming back to here. So this one equal to 3, maybe 3.4, 3.5 here. Okay, there will be some intersection there, right? Some intersection there. Okay, then you got it complex pole. That means you will have the departure angle, right? Okay, so how to find the departure angle? Now you need to connect all pole, right? So this one and this one. So this one is 90 degree, done. And this one, yeah, sometimes it will make you confused about it. So this one is 1, and this one is 2. All right. So you only have 3 pole, 1, 2, 3. Okay, good. So that's means we need to find the angle to this one first. And before that, you can find the angle to this one, right? So you can get it tangent theta is equal to over 1. So theta is equal to what's wrong? What's wrong is it? Can somebody look at that? Minus 1. Okay, ini ada yang salah kan? Example 4.1. Okay. Alright. In this slide, I think it will be some mistake there. This one will be equal to 1, right? Time, right? Betul tak? Guys? Betul kan?
Tak ada kata letak 2 dekat
Okay.
lengkar.
Betul. So this one is equal to what? 64, right? And this one equal to 116. Okay. Please correct that one. Alright. and you can got it 116 here, and then this one you got it 206 here. Okay, 206 here, and then you got it is 26. Okay. Right. Okay. Sorry guys. So you need to update the notes, right? Okay. Done. Okay. Now we can get it is here. Here is 116 degree, and here is 90 degree. Okay, good. All right. So how to find the departure angle? Departure angle you have here. Right. The departure angle, so 180 minus with summation of pole, and then plus with summation of 0 here. Okay, so 180 minus with pole, you got it is 90 degree, plus with 116 degree, and you don't have 0, and then you will got it is minus 26 degree, right? Okay, right. Done. So how to draw at this point? Minus 26 degree. So this one and this one will be minus 26 degree. Okay. So the departure angle, it will go to this one, and then it will meet the what we call it, the asymptote, and then it will go to this. Okay. And this one will be minus. Okay. So of course, this one will be plus 26 degree. Then the cross one will be go to this. Then it will go this. Okay. So this is the locus. Right. Okay. Can you get it? Boleh nampak? Boleh dapat tak? Sorry, I'm not. Yeah.
Doktor, kalau for the 116, so contoh 64 degrees tu kan,
Yes.
do we need to like round off terus 64 sebab I got like
boleh.
no, sebab tadi saya dapat
63.4.
so yeah. So which one is correct? Yang 63.43 ke ataupun 64?
Yeah. So that means actually, yeah. So actually for the what we call it for the angle, right? So I think you can choose whether 63 or 64 is okay lah. That mean you can round out, right? This number, right?
Yes.
To make it easier. So that if you want to plot by using the protector, it is quite difficult to make it 63.4.
Yes.
Okay.
Yeah.
So try to round out. All right.
Okay.
So good. You have this focus and so on. Okay. Remember, we got it is k equal to 52, right? K equal 52 is the maximum one. This one. So that means this is k equal to 0. So when the k is increased, right? K equal to 1, k equal to 2 until k equal to 52. So this is the maximum one. Okay. Can you get it? Faham tak? Okay. The maximum one. Also with this one is 52. K equal to 52. Okay. So now if you look at the block diagram here, right? if you put to k equal to 52, that means your system is the maximum what we call it stability of your system. Okay, right? So you have draw the block the root locus there to describe the maximum one. Okay, if I can show you, where is it? Okay, maybe example. Is it this one? No, this one. Yeah, this one I think. Or 1 plus. Okay, not this one. I don't have it this one. Okay, never mind. The root locus. The root locus. Okay. E plus master control engineering slide. MATLAB. Chapter 4. Okay, root level integration. Okay. Yeah, this one I think. So when you draw the locus, yeah, it's something will be like this one. So you can see that the gain equal to 52, it will be your what we call it your stable, the final one for your system will be stable. Okay, right. Okay, but a lot of damping overshoot and so on from here. And this one, the root locus for another one, right? 52. Okay. And you can look at there is the damping ratio, right? So for your root at the real axis, you can see the damping ratio equal to 1. And for your root, right, at this one, the damping ratio is between more than 0 and less than 1. Okay, so you can see that, right? More than 0 and less than 1. Okay, so this one we can say that our system, right, is react at the second order response, right? Because there are two root that dominance, right? So we can say that, right? Okay, now let's move. Okay, if given the k equal to 10, the root of characteristic equation minus 3 and plus minus 2.24j, determine the damping ratio, natural frequency, and time constant. Okay, let's look k equal to 10. K equal to 10. Yeah, almost there. So it give you 2.24 y minus 1. Yep, minus 1 and 2.24. This one k equal to 10 also. K equal to 10, 10, 10, 10 equal to, yep, minus 3 here. Okay, right. Okay, so when you got it, k equal to 10, it is like, if you look at this one, k equal to 10, that means you will draw some line here, first here. Okay, you can look at. So this one is equal to k equal to 10, then it will give you the root value for this one. Okay, and also k to 10 here, root value for this one. Okay, so for the k equal to 10, we want to determine what is the time constant, what is the damping ratio here, what is the omega n, okay, and omega d damping ratio. Alright, so now what you need to do is you need to apply this one. Okay, right. Now you got it here. So you got it here, and this one it give you is maybe we can draw like this one. 2.24J. Okay. And also same thing with this one, minus 2.24J. And okay. This one you get another one, minus 3J. So what the information that we can get it from here, for this one is minus 1. So that means this is equal to 1. This one equal to 2.24. This one equal to 1. So we can get it here. Okay. This is beta. Right. Okay. So you got it for S1 equal to minus 3 for this one. You can get it minus omega n equal to minus 3. Okay, so damping ratio you can get it is minus equal to 1 omega 3, so equal to minus 3, and then you can get it equal to 3. Yeah. Okay, and then for the time constant, t equal to 1 over damping ratio omega n. You can get it here 1 over 1 times 3, so equal to 0.33. Alright, and then from this one you can get it omega d is equal to omega n square root 1 minus damping ratio squared. Right, so from this one you can get it is 0. Okay, so for this root you can get all the information here. Okay, alright, so let's look on this root. Okay, so for this root, this both root, what you can get it is omega n. This one will be your omega n here. Okay, so for the roots equal to minus 2 minus 1 plus minus 2.24J, then we can get it omega n. You can get it this is the hypotenuse, so square root 2.24 squared plus 1 squared, you can get it from here. Okay, equal to 2.45, and then you can get it omega d. Omega d, that means this point, so it's equal to 2.24. And then from this one you also can get it the damping ratio. Omega d is equal to square root 1 minus omega n square root 1 minus damping ratio squared. So from this one you can get it the damping ratio is equal to 0.405. Okay, and we also can get the time constant lah if we want. So can get it here 1 over 0.405. You time with omega n 2.45 is equal to 1 second. Okay, alright, so from this information we can get it at the k equal to 10 here. Okay, so we can get it. We can get damping ratio is 0.405, and the time response 1 second, and omega n is 2.45. Right, so from this one we can draw our response lah. You can draw again the second order response based on this one, right? Okay, right, so remember how to draw, right? You can get back the MP, and you also can get the first peak and second peak and so on. So we can say that this is the third order system. So we can say that the response is react at the second order system. Okay, is it too fast? Is it too fast? Boleh faham Clear? Clear Boleh? Boleh tak? Boleh faham tak? Little bit too fast. Okay. So for the root locus, I think it's clear to you. For this one, we want to find the parameter time constant, the damping ratio, omega n and omega d. So omega d, we can get it straight away from here, right? This one is omega d, right? And omega n is this line. So this line, we can get the hypotenuse. So this one, squared, and square root, we can get omega n. Okay. Okay. All right. And for if you get it omega n, omega d, you can get the damping ratio here. Okay. And then from the damping ratio, you can get the time constant also if you want. Okay. So this is how you interpret your locus, your root locus. Okay. Boleh tak? Clear? Right. Okay. So this is where we want to know. Oh, if the k equal to 0, how much, or that means what is the value of your damping ratio? Because your damping ratio will determine how much they overshoot and so on, right? Okay. How much the natural frequency? What is the value? All right. Okay. Do you have any question about this one before we go to the last example? Okay. No? Ada apa-apa soalan ke, guys? No, sir. Okay. Good. So we go to the last example, but this last, I think it will be new knowledge for you. A lot of you don't know how to use the calculator to solve the simple thing. Okay, we will look into that. All right. This example 4.2, the last one. For a control system shown below, choose the value of K such that the maximum damping ratio is 0.5 and the time constant is less than 1 second. Okay, we are given that we want the damping ratio is only 0.5 and also the time constant is less than 1 second. Okay. So this is our objective. 4.2 here. So now we want the damping ratio is equal to 0.5 and the time constant is equal to 1 second. That means less 1 second lah. So you are given the block diagram here, okay, and so on. Then you start to draw the locus. Okay, you start to draw the locus. Okay, blah 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 blah. You draw, and then you got it this kind of root locus here. Okay. All right. So maybe I need to draw it also to make sure that you can understand. Right. I just draw the root locus. Okay. Me too, doctor. Sorry, doctor. I have test. Okay. Yep. You can leave the meeting now. So later on, maybe you can learn it from your friends. Okay. This one you got it with 0 here, and then you got it another one. This one, okay, 0, and also -4. Okay, so that means your root locus now going to this. Done. Then this one, try to find other one. Okay, done. Then you got it something, a break point here, and then it will go to this, and another one go to this. Okay, so done. Right. Right. So clear, this one we already got this. This one is imaginary, J, and also real, I and G. Okay, now you want to achieve the objective that they want. So that means the damping ratio equal to 0.5. So what can we got it from here? the damping ratio equal to 0.5. So remember the damping ratio equal to cos beta, that's mean the angle there. Then you can get it the beta, right? 0.5 equal to cos beta. Then you can get the beta is equal to 60 degree. Right? So what you can do is you draw a line. This one is equal to 60 degree. Then you got a point here, right? Okay, right? And this point, it give you, right? That's why when this type of question, you need to draw it based on the graph, right? It give you this point, 2.46J, okay? And then minus 1.43. Okay, this point. All right, so I write it again. Minus 1.43, okay, plus with 2.46J. Okay, so we want the damping ratio here. So 60 degree will give you this damping ratio equal to 0.5. Okay, clear? Right? This is your root locus. Okay, so at the damping ratio equal to 0.5, that means 60 degree. So you got it this point, 2.46, and that's 1.43. Okay, so the question is, he asks you, what is the value of K? What is the value of K here? Okay, so our objective is we want to know what is the value of K here. So for this one, what is the value of K here? Right? This one, we know that K maximum, we can get it from the root table, right? I'm right. Okay. So we want to know what is the value of K here. Okay. Right. Okay. Okay. So in order to find the value of K here, right? Right. So you can do that. You can KGH, the open loop, right, equal to 1. Right? KGH equal to 1. That means your KGH you are given from the this point. Okay, the magnitude to the point of the KGH equal to 1. Okay, that means you have all these four, right? So we want to know this length. Okay, what is this length? Okay, and your another one, okay, you get it, this one. Okay, what is this length? And another one is this one. What is this length? Right? So this one, this length times this length times this length is equal to 1. Okay? Alright. Good. Then your KGH here, then you got it is KGH here is equal to, yep. K S plus 4 and S plus 10. Okay, so we want to know the magnitude for this one. That means this point need to minus with this point, right? Then we can find the magnitude. Okay, so it's equal to K, right? Minus 1.43 plus 2.46 J. You minus with 0 this point. Then we find the magnitude. And you time with, okay, and then you time with this point also minus with this point. So minus 0.143 plus 2.46J minus with this point, that's mean minus 4. So minus with negative 4. Okay, done. And then another point is minus 143 plus 2.46j minus with this one. This point is minus 10. Minus 10. Okay, done. So all this one is equal to 1. Okay, so you can look at this one, right? Okay, and then after you look at this one, you just minus 10. That means it become 8.57 plus 2.46j times with this one is 1 and equal to 1. Okay, and then after that, you can find the magnitude and then you can get k equal to 19.3. Okay, my question is, how can we solve this one by using the calculator? Alright, do you know how to do that? Awak tahu tak macam mana nak buat using the calculator? It's not using the Excel. Okay, alright, now take out a calculator. I will show it to you. Alright, you don't need to, that means you don't need to write and so on, you just use your calculator. It can be solved by using the calculator, not Excel. Excel will take about more than 30 minutes. Okay, now you can see that. Boleh nampak tak? Boleh?
Boleh
I'm going to show you. Okay, I'm going to show you. First, you choose a complex, right? So you can go to mode, right? Mode setup, you can choose the complex. You press it, and then you choose the complex number 2. Right? So you already got the complex, right? Okay, done. Okay. Alright. Now, this one, the point this one, right? We save it to one variable named A. Boleh tak? Okay. That means what we have here is we have k divided with a minus 0 times with a minus, that means plus 4, a plus 10 equal to 1. Okay. We want to find this k. Okay. So we're going to do that. So now you put the value of a here, put the value of a here, minus 1.43 plus 2.46i. Boleh nampak tak? Boleh nampak? Okay, boleh Boleh nampak tak? And then you press the equal, so you got it this one. Boleh? Dah, sengap je. Dah tak nak ikut dah.
Boleh kata.
Boleh. So, how we going to save this value, right? To one variable such as a, right? So how to do that? So you can take the alpha, right? Press the alpha and a, right? Alpha a, so the a will come out, and then you press the answer. Oh no, sorry for that. Yeah, need to type. Okay, sometimes I forgot. Minus 143 plus 2.46 I. So alpha a and solve. You got it, alpha a and solve, right? Solve it write a question mark, right? A question mark, and then you press the answer and equal. Now it will save the value, this one, the value to variable a. Can you do that? Boleh?
Lepas A tadi, kita apa nak tak?
Tengok. Mesti you tak pernah buat kan? You tak pernah buat ni. Okay. How I'm going to show. Okay, I hope that you can get. Okay, I will repeat back. Minus 143 plus 2.46 I. Okay, this one done kan? Right. Minus 1.43 plus 2.46 I. Okay, this one done. Okay, Done.
Yes.
Okay, you got this one kan? Ini dah dapat kan? Okay, dah dapat. So, alpha and A. This one kan? Alpha A. Nampak saya tekan A ni. Alpha A, dia keluar ni kan? And then you take calculate, cal or solve. Calculate. Dia keluar tanda soal kan? Dia kata A equal to what? Okay. So, and then you press answer and equal.
Equal.
So now this value are saved in variable A.
Okay.
Boleh? Okay.
Hmm.
Alright. Kalau if you press AC, right, or maybe you close, right, you close your calculator, you can check back the value. You can press alpha and A. You put it equal, press it equal. So you can see, yeah, the value is already saved in your calculator. This is a new thing, right, for you?
Yes.
Yeah.
Tambah satu.
Yeah. Your friend also shares that tekan shift plus RCL, right? And plus any variable to store pun boleh save. Yeah, good. Your friend pun boleh buat macam tu. Good. Amir, thank you very much. Okay. Fine? Done kan? Done.
Yes.
Okay. Done Now we're going to apply A minus 0, A plus 4, A plus 10. So you just put it parenthesis or kurungan there. Alright. So take your alphabet, alpha A minus 0. Alright. You time with A. I will type first lah. Okay. A plus 10. Okay. Done. Okay. Boleh
Boleh.
And then you press equal. You press equal, you got it. 96, right? 96.3. And this one is I, right?
Yes.
In complex number. Okay. So how to change this complex number to magnitude and angle? So you can see that where is it? I think this one. Okay. In this calculator, you can see that the number 2, right? The number 2 here has a complex. The name is complex. The number 2 has a complex, right? So you just press shift, and then you just press number 2 here. Okay. So the words will come out argument or art and theta conjugate, and this one the complex. So we choose number 3. So you choose number 3, and then you press equal. So it will show you this is the magnitude 19 and also the angle. Okay. It's a new thing for you, right?
Yes, sir.
Okay.
My-
Now we got it. K here is equal to 19.3. We just round it, and then the angle is 170 degrees. But we just want the magnitude 19.3. Okay. So simple, right? Right? Clear? Done.
Boleh. Done. Okay.
Happy this a new thing for you. So I repeat it back. How to find the value for this K at this point, right? You already know the point, right? 1.43 based on this angle. So how to find the K value? You just minus this point, minus with this one. You got it length here. We want length here. This point we got it length here. This point we got it length here. Or it have a one formula kgh magnitude equal to 1. Okay. So your kgh here is this one at equal to 1. So how to solve it? Just put it this point minus with this point, time this point minus this point, time this one minus this one. Okay, got it. Okay. All right. So if you want to look at the the example 4.2 here. So we can run it. Okay. Now for k equal to how much is it? 19.3 here. Yep. Okay lah, boleh lah. So you got it, the pole minus 1.43 plus 2.47, right? We got it 2.46, it's okay lah. Damping ratio, yeah, we have achieved 0.5, okay? And then K is 19.8, you got it 19.3, okay? It's okay, right? Right? So if you got it another value, for example, this one you got it minus 0.93 plus 4.07, then you can save this value to variable A, and then you can minus back, minus to all pole, and then you can get the gain 2.11. Believe me. Okay. All right. So we have answered this question. So they want you to find the K value. Okay. Do you have any question?
Doktor, for yang angle 179.9 tu, dia kita kena bagi tahu juga
Tak, dia tak perlu. Because we only want the magnitude. We only want the magnitude only. So we just take it, the magnitude, this one. Okay, we just take it 19.3.
Okay. So yang 179 ni angle kat mana, Doktor?
Angle, tak tahulah nak kata angle dekat mana. Alright.
Thank you, Doktor.
Okay. But there are two methods. So whether you calculate it using using the calculator, that means you need to type again this one minus 10, type again this one minus this one. It will take a lot of time, right? So you just use your calculator, save it to variable A, then so this I think is a new thing for you. Okay? Ataupun dah pernah buat, ada lah kan. Okay. Alright. Last but not least, any question? Last one? No?
No, Doktor.
Okay, good. So what I'm going to tell you, we can get the K max, right, by looking the intersection. But how to get the between the K around this one? So we need to do this formula. Okay. All right. So I think that's it for our class. Sorry for drag for 2 hours, right? Because I'm going to finish this chapter and this week, and then we can concentrate on the next chapter. All right. I wish you stay safe and happy holiday next week. Right? There is no assignment for these courses. I will see you again on following weeks. All right. So stay safe. If you have any question, you can ask me. All right. Okay. That's it. Thank you for your attendance. All right. See you again. Bye bye. Assalamualaikum.
Okay, Waalaikumsalam.
Okay.
Thank you, Doktor.